Okay, fourth grade. Today for lesson 14, our objective is to solve word problems involving the addition of measurements in decimal form. So we're going to solve a bunch of word problems. That's it. So we're going to jump right into the problem set. No application problem today. Page 99 in your blue Learn books. Barrel A contains 2 7/10 liters of water. Barrel B contains 3 9/100 liters of water. Together, how much water do the two barrels contain? So what do we see here? Important numbers, right? I see barrel A, 2.7 liters. I see barrel B, 3.09 liters. 2 7/10, 3 9/100. I see together, tells me I'm going to be adding, right? How much water do the two barrels contain? That was just a quick cubes, right? I've circle boxed, underline. I don't see anything to eliminate, and now we can solve. Just as a visual, let's make a quick tape diagram to highlight our unknown part and the parts that we do know. Three and 9/100, 2 7/10, right? We've got barrel A, barrel B, and together they're going to give us W for the amount of water, total amount of water. So that's our missing hole that we need to find. You could show these values as fractions, but since today we're focusing on adding in decimals, I'm going to set myself up to add these numbers together just the way they are. If you were going to represent them as fractions, you could show 2 70/100, which is the same as 2 7/10, but if we change the denominator to hundredths, that lets us easily add it to 3 9/100. Our 2 1s plus 3 1s will give us 5. And 70/100 plus 9/100 will give us 79/100. 5 and 79/100 in fraction form. Now we want to show the same thing in decimal form, which was our objective for today. So again, we want to add our 1s, 3 1s plus 2 1s gives us 5 1s. We have a 7 in our tenths place and a 0 in our tenths place. And then we have a 9 in our hundredths place and a 0 in our hundredths place. 5 and 79/100. Let's not forget, right? Liters. And if we're also following the RDW strategy, we read, we drew, and now we need to write that the two barrels contain. And remember, we have to write in decimal form today. That's our objective. 5 and 79/100 liters of water. That's a 4 out of 4 response. Number 2, Alyssa ran a distance of 15 8/10 kilometers 1 week and 17 34/100 kilometers the following week. How far did she run in the 2 weeks? Our question's jumping right out at me here. In the 2 weeks tells me that we're going to be adding. She ran 15.8 kilometers 1 week, 17.34 kilometers the following week. Kilometers, 15 and 8 tenths, 17 and 34 hundredths kilometers. Let's give ourselves, again, just like we did above, a tape diagram to keep our problem clear in our head, sort of visually, so we remember what we're doing with these numbers. We have 17 and 34 hundredths, and we have 15 and 8 tenths. Together, they're going to give us how far she ran in 2 weeks. That distance we'll call D. Uh, 17 and 34 hundredths, if we were using fractions and we wanted to make them compatible so that we could add them together, right? Because that's what we're doing here. We're combining, adding values. 17 and 34 hundredths plus 15 and 8 tenths. Remember that by multiplying the numerator and the denominator by 10, we can turn 8 tenths into 80 hundredths. Now I can add my hundredths together because they have like denominator. If they have like denominator, then I can combine my numerators to make one combined value. So we are going to add 17 ones and 15 ones. Together they give us 32 ones. And 80 hundredths and 34 hundredths gives us 114. We had 80 and 34 hundredths. 114 hundredths, of course, is worth more than one. It has one whole in it, 100 hundredths we can take out to make one whole, so it becomes 33 and 14 hundredths. Written as a sentence that would say, she ran 33 and 14 hundredths kilometers in 2 weeks. Okay, number 3. We're on page 100 now. An apple orchard sold 140 and 5/10 kilograms of apples in the morning and 15 and 85 hundredths kilograms more apples in the afternoon than in the morning. How many kilograms of apples were sold that day? Okay, now we're getting tricky. There's 2 things you have to do here. And we're not just adding like we did for number 1 and number 2. We have 2 values, right? We have the morning and the afternoon. So if we're making a tape diagram, we have 140 and 5/10 in the morning. Morning is AM, right? In the evening, or in the afternoon, which we're going to call PM, they sold 15 and 85 kilograms more apples in the afternoon than in the morning. So the value for the afternoon is more than the value in the morning by 15 and 85 So we need to add the original AM value, the morning value, to the afternoon value, but the afternoon value is the morning value plus 15 and 85 right? If we're cubing this, more apples in the afternoon than in the morning. That than tells us we're making a comparison. More how many total kilograms of apples were sold that day. So we need to add these three values, three individual values together. So I think the easiest thing to do there is let's first do 140 and 5/10 plus 140 and 5/10. If we add them together, our wholes will be 140 plus 140 will give us 280. And 5/10 and 5/10 will give us 10/10, which we know is the same as one whole. So that's 281. Now that's our two 140 and 5/10 values. We still have 15 and 85 that we need to add together to what we already have with 281. Adding these values together, 281 plus 15 and 85 we have 85 in our decimal places. We have 6 in the ones, 9 in the tens, 2 in the hundreds. 296 and 85 kilograms apples were sold that day. All right, now number 4 we'll do together. Number 4 is very tricky. A team of 3 ran a relay race. 3 people, 3 values. The final runner's time was the fastest, measuring 29 and 2/10 of a second. 29 and 2/10 seconds. That's the fastest time. All the other times will be longer than that. If it's the fastest time, that means it's going to be the lowest value, right? So our other times are going to have to be more than that. The middle runner's time, this is a relay race, so they take turns running sections of the race. That last runner was the fastest. We'll call that runner C. The middle runner, we'll call B, was 1 and 89 hundredths seconds slower than the final runner. So that's going to be 29 and 2/10 plus 1 and 89 hundredths. The starting runner's time, we're going to call that runner A, was 9/10 of a second, 9/10 seconds slower than the middle runners. So this last runner is going to be 29 2/10 plus 1 89/100 plus 9/10. What was the team's total time for the race? So we need to find these three values, A, B, and C. Then we need to add them together, A plus B plus C, in order to find the total time. We'll say T for time. All right, so we've got 29.2 seconds. Then we've got 1.89 seconds slower. Then we've got 0.9 seconds slower than that. So first thing we need to do is take 29 2/10 and add it to 1 89/100. 29 2/10 converted to hundreds is 29 20/100 plus 1 89/100. Add that together and we get 31 9/100, right? Because 20 and 89 gives us 109/100. Take out your 100/100, add it to the ones, 31 9/100. That is C. I'm sorry, that is B, right? We already know C. So B equals 31 9/100. A, the first runner, will be 31 9/100 plus another 9/10. Well, that's actually pretty easy to add kind of mentally, right? We can do 31 9/100 plus 9/10. Well, we're going to put a 9 in the tenths place, add that to the 0. That'll give us 31 99/100. So if we have these three values, all we have to do now is add them together. Easy. So we have 29 2/10, 31 9/100, and 31 99/100. This would be a great example of a time when we can start using our calculators, right? Especially if it's a test or the PSSA, you want to add it mentally, add it yourself on paper, and then check your work with a calculator. But if we're adding these values together, let's put a 0 in our hundredths place up here. We can still use old-fashioned addition to add these values up. Just don't forget about your decimal point. 9 and 9 will give us a 1 in the tenths place and an 8 in the hundredths. 9, 10, 11, 12. Don't forget your decimal. 9, 10, 11, 12. 92 and 28/100. The total time for the race was 92 and 28/100 seconds. Okay, I want you to continue on to page 101. There is only one question to do for the exit ticket. It is not as hard as the one we just did. Okay, your exit ticket says, Elise ran 6 43/100 kilometers on Saturday and 5 6/10 kilometers on Sunday. How many total kilometers did she run on Saturday and Sunday? You are combining those two values, adding them together. Make sure to show it visually and represent everything just the way we did in the problem set, and you will do that exit ticket just fine. Thank you, and see you tomorrow.